Okay, to make you more understand, okay, again, if you refer to the next slide, okay, that is what you can see there. Image processing is more to the low level side, image analysis more to the middle level side, while the computer vision is more to the high level side. So to make you more understand what actually the difference between these three elements, I would like to discuss about this slide that I just create. Okay, this one. Okay, in order for you to get more understanding what is the difference between image processing, image analysis, and computer vision, I will like to highlight this typical block processing, a common block processing that involve in what we call as an autonomous machine vision system. Okay, what is the meaning by autonomous machine vision system or autonomous machine perception system? Is the system where the 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 input of the system is the image, and you are processing, you are doing a processing and do some, you know, intelligent intervention into this inside the system, where the system have a capability to, you know, interpret the image, the input image that you provided in the system. Okay, uh, there's a lot of a system that we can categorize into autonomous machine vision system, like the example that I will show in our previous lecture, like PCB inspection, intelligent PCB inspection, that can considered as a machine vision inspection system. And what else? Okay, the process of removing, for example, the human computer interactions application there by using gesture, that is also considered as a machine vision, autonomous machine vision system. Okay, so in general, this is the processing block involved in a machine vision system or autonomous machine vision system. Okay, it started with, of course, the analog image is obtained from the environment, and then the first block should be image acquisition, that we have uh, we have know this so far based on the previous poster as well as previous lectures. Okay, and then then we have a pre-processing there. Let me go through this slide. You can see that I give you some one of the example of um, autonomous machine vision system, which is, for example, okay, let's say I also use the same example as the previous poster that I show you, which is the cross section CT scan image. And then of course this is this is just example. You can put any example there, anything that uh, where the input is image, and then that system are capable to interpret something intelligently, that we can consider that as a autonomous machine vision system. But in this case, we just give you some example which is similar to the previous poster that I show you before. Okay, again, let's say from the environment you capture the image. Of course, in the image acquisition process, that's involve the CT scan as well as the CCD sensor, so you can obtain the digital image in this, where you obtain this digital image. However, unfortunately, the digital image is affected with certain noise, so that's why the second block is pre-processing. Okay, so by applying pre-processing, then you manage to remove the noise. So in general, pre-processing here involve many approach, or many sub block or sub process of image processing, such as image enhancement. So this one, okay, can be consist of many sub process block, uh, which is including the image enhancement. Okay, image enhancement, it also can have image restorations there. Okay, image restoration that we have explained before. So in general, pre-processing always involve these two elements, which is image enhancement or image restoration. And in some application, maybe they only use image enhancement. Okay, it's depend on application, or and what are the suitable approach to be used in the system. And then the next process is segmentation. Of course, I have explained to you what is segmentation. So by applying the segmentation, then you can separate between the background the pixel belong to background and the pixel belong to your region of interest. And then the next process is post processing. Okay, the post processing over here actually is your morphological processing, which is you will learn in you will learn this one in the last chapter. Okay, morphological processing, which is also explained in the previous poster. Okay, and then after that, okay, for example, let's say this system actually they want to detect whether this vessel, blood vessel, is normal or not. Okay, the main purpose of the whole system is to interpret given this CT scan image, and the system be able to classify between normal and abnormal blood vessels. So of course, this is the general process involved. The first is image acquisition, the second one is pre-processing to remove the noise and to enhance the image, and then the third one is you applying the segmentation because you want to highlight the region of interest, which is your blood vessel. The pixel belong to that blood vessel, or I think aorta there, and then meaning that the rest or the pixel belong to other tissue should be black, and then you only leave the region of interest as white. However, due to the limitation of segmentation, you applying a post processing. In general, that should be a morphological processing, so you can remove that small sharp point where that pixel actually is failed to be identified as background in segmentation process. And then this block actually is not covered in image processing, what we call as a feature extraction. From the feature extraction, actually you can extract the meaningful features or attribute from the image. Okay, this is, I just give you some example, like from this white block you can extract the parameter, meaning that you measure the parameter of this white block. You can also measure the area of this block, and then you can measure the bounding box. I mean, you draw the bounding box of that can fit that the white block can fit into this bounding box, and you measure the width and the length of white box, and that point can become your features as well. And then of course, that is called geometrical based features. We also have a color feature such as this one, which is average intensity value. Okay, this thing is not covered in your class. Okay, I just give you some idea actually what the whole process involved. The feature extraction is, the purpose of feature extraction is to extract a meaningful features, okay, from the image. And once you get a good features or the best features, then you fit into this block, what you call as a classification. Okay, at this block over here, okay, this is where the AI involved. Okay, especially machine learning, such as the artificial neural network. You can also use k nearest neighbor, or you can use SVM, or also you can use what else, okay. The purpose of classification is that once you fit the features in this block, it will capable to decide whether, okay, this image is belong to normal or abnormal. Okay, meaning that the output of classification is the label, or the label or the interpretation of the image, whether that image is belong to normal or abnormal. So that's how it's work in a typical autonomous machine vision system. Okay, that's how it's work. So from this block diagram, as you can see there, okay, I would like to explain here. So now, okay, just skip that things first. Okay, this 3 point is actually image processing. So why I said that? Because the input of at this point is image, and the output at this point is image. So this is the output, and this is the input. So input image, output image, so it's image processing. Image analysis is this one, because the input is image but the output there is attribute. Okay, output over here is attribute or the features. That is image analysis. So how about computer vision? Actually the whole system itself is computer vision, because the input is image and the output here is the interpretation of the image. Okay, it's an interpretation of the image where actually or the label of the image. So now you can see the boundary there's where, or the territory, which one is belong to image processing, which one is belong to image analysis, and which one is belong to computer vision. In other words, autonomous machine vision system is another name for computer vision. Actually, if you see, computer vision also include and is also cover this one. Okay, this one is just a hardware that, okay, the hardware that convert the analog image into digital image, but actually the whole system actually is called computer vision. Okay, the one that process the image, enhance the image, is image processing. The one that extract the good attribute or the good features, that is image analysis. But if you integrate this system with some AI over here, because this is the one that involve AI, then it's become computer vision. So I hope you understand how to differentiate between computer vision, image analysis, and image processing. Now the question is the reason approach, which is called, of course now AI is very prominent nowadays, and the AI is very prominent is because of one approach which is called deep learning. Okay, in deep learning, okay, nowadays if you go through any deep learning article or source, you find out that deep learning, one of it is in the process is like this. This is your image. Okay, assume this is your digital image, and this is your deep learning blocks. Okay, deep learning. Okay, deep learning block, and then the output actually is your image interpretation. Okay, is your interpretation or label of the image. So I think if you go through any deep learning course, you find out nowadays there's a one deep learning approach called CNN. Okay, CNN. Okay, they call it CNN, or in other words, it's CNN. The input is image, the output is interpretation or label of the image. So in other words, actually you can see that the CNN itself, or the deep learning block here, because the input is image, the output is interpretation. So now what is this one in image processing community? Of course, if the input is image and the output is interpretation, then actually this is computer vision. This is also called computer vision. Okay, computer vision. So the what is different between this one and the conventional computer vision? The conventional computer vision involve many block process, sub-block process, where image processing, image analysis is involved in each and every process here, while the recent or the prominent AI called deep learning, and the one that apply for image is called CNN. They only use one single block where you cannot separate it into sub-block, because that network work alone in doing processing, pre-processing, segmentation by itself. We don't know which network layer is done that part. Actually it's integrate together to recognize image or to label image, or in other words, the input is image, the output is the label of the image or the interpretation of the image. So here you can see that is why deep learning is not, or the AI is not so far from the computer vision community or image processing community, because you can see here, if you apply deep learning into image and the output is interpretation, now it's actually is computer vision. So that's why what I will like to highlight here is that computer vision and AI is not so far, it's integrate together. If you apply the deep learning where the input is image, then it's become computer vision. Okay, unless if you apply the deep learning where the input is one dimensional signal such as ECG or EEG, then it's become some sort like image processing system. Okay, for one dimensional signal we don't have many different terms. Okay, they just call the whole system here as a image I'm sorry, the digital signal, or sorry, a signal processing system. But for image processing community, there's a three term you need to remember: image processing, image analysis, and computer vision. That's why for those who claim that he or she expert in image processing, for sure he also claim that he also or she is expert in computer vision, because it's not so far, because it integrate together. And nowadays when the image processing when the artificial intelligence involved in many area, including the area of image processing and computer vision community, which is why the AI is also close to those who doing the computer vision. Okay, I hope this video helped you a lot in define what is computer vision, what is image analysis, and what is image processing.